All right, so we are talking about quadratic functions, right? And basically, what do we use a quadratic function for? We use quadratic functions to model situations where something increases and then decreases over time, okay? And this particular function, we know it's a quadratic function because the highest exponent that we see is a what? A 2. Whenever you have an exponent of 2, you know that this is a quadratic function, and when you graph it, it's going to look like a parabola, okay? What is a parabola? It is the shape of a what? A U. It either U's down or it U's what? Up, right? This particular one U's up. How do I know that it U's up? Because the A is positive. So watch this. This is the standard form. This is the standard form of a quadratic function, right? Standard form of a quadratic function gives us an A, what's in front of the x squared. It gives us a B in front of the x, and it gives us a C, which is a constant that is sitting by itself, right? So this particular one has 4 terms. This only has 3 terms. But can we simplify this? Yes? What can we simplify this to make this? What can we combine? Positive 4x and? What happens to positive 4x and negative 4x? They become what? 0. Or do they just become x? 0. Why not just x? They're opposite, so they're going to do what? Cancel out. But why not 1x? Why not write just x? What's the imaginary number in front of a variable? So 1. So if I were to put 1x, the x's are not disappearing, right? They're not canceling out. It's leaving me with 1, right? So we don't want to leave 1x. 4x, take away 4, it's going to be 0. That's 0x. Are y'all with me? So if I rewrite this function in standard form, it would say y equals 2x squared plus 0x minus 8. I want you to look at that for a second and see why that makes sense. Does that make sense that this becomes this? 2x squared. Positive 4x and negative 4x cancels out. Become what? 0x, right? Because what's 0 times x? 0. Do I really need it there? No, because what's going to happen to them? They're going to cancel out. Are y'all with me? Is 0x the same thing as x? No. 0x is 0 x's. X is 1x. Are you following? And then I have what? Negative 8. Is everybody following me? Yes? Now, what other way can I write this? I can write it as y equals 2x squared minus 8. We now only have 2 terms. Are y'all following me? Yep. Yes? Why? Because this second term cancels out. It's really nothing. Is everybody with me? Now, what do I want you to do? I want you to identify my A, my B, and my C because these are important things that we got to know for this. What is my A in this quadratic function? Oh, it is not 2x squared. What is my A? 2. It is whatever is attached to x squared. Are you all with me? It's the coefficient. So my A is just 2. What is my B? 0. Is it 0x?
No.
What is my B? It's attached to the x. It's not including the x. What is my B? It's just 0. And then what is my C? What is my C? It's negative 8. These 3 things are going to be very important for you to be able to identify as we learn other ways to solve quadratic functions. You're going to have to be able to pull out the A, the B, and the C and use them in order to solve the quadratic function, right? But for today, we can leave it just like this and identify our A, B, and C. Is everybody good? Now, the different parts of the standard form tells you something about the quadratic function. So let's start with A. And you can do this in your notebook. Before we solve this, I want you to do what I'm doing. The A tells us our concavity. concavity. The A gives us our concavity. What is concavity? Concavity tells us how wide or how narrow we are. Bless you. Concavity is all about the bend. It tells me all about my bend. It tells me if my bend is wide or if my bend is narrow. Watch. Wide versus what? Narrow. It also tells me if I bend up or if I concave down. Do I concave up or do I concave down? How can you tell that from all that? Well, watch this. The bend, whether or not it's positive or negative, determines if it's up or down. Our A is positive. The A is 2. It's positive. So guess what? This bends up, right? What if that A would have been negative? So that means it bends down. It concaves down. Are you with me? That's very easy to determine. They're going to give you an equation, a quadratic function, and they're going to say, pick which graph goes with this. And if you see that the A is positive, but you got graphs that you down, then you can cancel those out because they're doing the opposite of what you know it should be doing. Are y'all with me? So what does the A tell me? It tells me all about my concavity. If I U up or if I U down. If it's positive, we U up. If it's negative, then we bend down. Question. What else does it tell me? Does it tell you if you have a max or min? Can you tell if you got a max or minimum? Think. What is a maximum? The highest point. What's the minimum?
The lowest point.
The lowest point. So if I concave up, which do I have? Do I have a maximum or do I have a minimum? Look at it. Raise your hand if you say it's a maximum. Don't look at other people. Raise your hand if you say it's a maximum. Raise your hand if you say it's a minimum. Watch this. It concaves up. Do I have a lowest point? It's going to be here. Do I have a highest point? No, because what's on the end of each one of these? Arrows, right? And what do the arrows tell us to do? Keep going. If you got a parabola that U's up, isn't this what it looks like? So are you going to have a maximum, which is the highest point, or are you going to have a minimum? You have a minimum. If your parabola U's up, you have a minimum. If your parabola U's down, you have a what? Maximum. There is a highest point. Does that make sense? Yes? Can you pause? So what does my A tell me? My A tells me if I bend up or bend down. If I concave up, I'm positive. If I'm concaving down, my equation has a negative A. Are y'all with me? It also tells me if I got a max or a minimum, right? Because Amoya, if it concaves up, then I got a minimum. If it concaves down, then I have a what? Maximum. So that's two things I can tell. If it concaves up or down, and if I have a max or a min, right? What else can it tell me? It tells me how wide or how narrow. Watch. A linear function is a straight line. Here's a linear function, right? What is the A on a linear function? Watch this. Y equals mx plus b. Linear, right? Yes? Y equals ax squared plus bx plus c. Look at them. If I take this and line it up, y how do these two compare? They got some things in common. They both got a y-intercept, right? You see this thing happening, right? But what is it missing? It's missing the ax squared. But what would make it miss the ax squared? The a has to be what? What's the only thing that can make this whole thing disappear? A got to be what? Because if A is 1, it don't disappear. It stays x squared. If A is 5, it doesn't disappear. Why? Because it stays 5x squared. So what does the A have to be to make this whole thing disappear? It got to be a what? 0. Because 0 times anything make that whole thing go away. Right? So what is the A on a linear function? It's 0. And this is what it looks like when the A is 0. When the A is 0, there is no bend. When the A is 0, it's just a straight line. What makes the bend? The A. Y'all follow? Here's what happens. If my A is, say, 1/4, it does this. What if it's 1/2? It does this. What if it's 2? It does this. What if it's 5? It does this. What's happening as my A increases? It's bending more. It's coming more and more narrow, right? So if the A is 0, this is what it looks like. There is no bend. It's not a quadratic function. It's a linear function. But the minute that A increases, it starts to bend. Are y'all with me? And it creates a quadratic function. Are you all following me? The bigger the A, the more narrow. The closer the A is to 0, the more wide. Are y'all following me? Now, what is bigger? What is wider? An A of 1 or an A of -1? What do we think? I hear A of 1. I don't know. Do y'all know the difference? What does a negative A tell us to do? Bend down. How far would -1 be further away from 0 than +1? No. So guess what? It's the same, right? Here's an A of 0, right? Let's say this is an A of 1. Guess what an A of -1 would be? Same thing, just down. So which one is wider? Neither. They're the same width. Whatever this is the same thing, except one is bending up and the other one's bending down. One is simply a reflection of the other one. They're the exact same thing as far as the width. Are you guys following me? Yes? So what does the negative tell me to do? It just tells me to U down, right? And it's going to be the same width as an A of +1. They're not different. They're not different. Are you all with me? All right? So let's say, I'll get into that later. So an A of 0 is really a linear function, right? If it's greater than, it U's up. If it's less than 0, it U's down, right? But the width, how wide it is, depends on how far from 0 it is. The further it is from 0, the greater your bend. Are y'all following me? Are you following me? I want to give you an example of that. I don't know if I can do that real quick, but watch this for a second. If, let's say I gave you, give me a second. Let me see if I can figure this out. Nope, that's not what I want. Nope, that either. I thought it was right here. Where are my tools? Oh, here they are. Nope, that's not them. I don't know. I don't know what I'm looking for now. Oh, there it is. Sorry. Good part. Here. 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 There it is. All right, watch this. So let's say this is a coordinate plane, right? And let's say we have a vertex right here. If I go out 1, up 1, out 1, up 3, it'll be the same thing on the other side. If this is 1 to the right, this is going to be 1 to the left. This is 2 to the right, so this is going to be 2 to the left. Do y'all see my parabola that's created? Yes? Okay, now watch this. This was a A of, I went out 1 and up 1, so it was an A of 1. Y'all with me? Now, I'm going to make another one, but watch what happens with this one. I'm going to do an A of 2. I'm going to start at the same place, but I'm going to go out 1 and up 2. And then out 1 and up 1, 2, 3, 4, 5, 6. It goes something like this. So then this would be 1 this way, And then this one would be, say, 2 this way. And this would be, I mean, y'all see what I'm trying to do, right? Not quite working out right, but this would be your parabola. Here's my question. Which one is wider? The first one or the second one? The first one. What was the A for the first one? What was the A for the second one? It was 2. So the further away your number is, your A is from 0, the more narrow it would be. I'm gonna give you one more example. I'm gonna do an A of 5, right? Starting in the same place. Watch what happens. Go right 1 and up 1, 2, 3, 4, 5. Then I'm gonna go left 1, up 1, 2, 3, 4, 5. You see this one? Y'all see that? Which one is more narrow now? The third one. Why? Because the A is further from 0. It is further from 0. So it's further from that flat line. Are y'all with me? So the point of this, what I'm talking about right now, is the greater your A is, which means the further it is away from 0, the more narrow your parabola is going to be. Are you all with me? Yes? All right. Any questions on this? All right. So A tells us what? 3 things. What does A tell us? It tells us if we got a minimum or maximum, because we know that it either bends up or what? Bends down. It's either concave up or concave down. If it concaves up, I have a minimum. If it concaves down, I got a, okay. What else does it tell me? So it tells me it's concavity, up or down. It tells me if I got a minimum or maximum. What else does it tell me? How narrow or how what? Wide. The wider it is, the closer the what? A is to what?
0.
To 0. That's it. It could be 1 unit this way or 1 unit this way. It doesn't matter. If it's positive or negative, it's still going to be close to the line. Are you with me? So the wider you are, the closer you are to 0, right? And then the more narrow you are, the farther you are from what? 0. And we're always looking at the A for concavity. Are you all with me? Does everybody understand that? Yes? We're going to talk about this a lot, but this is me giving it to you for the first time. I want you to understand. Is everybody good with that? All right. Concavity, concave up or concave down. Up is positive A, down is negative A. And if it's a positive A, then it has a minimum. If it's a negative A and concaves down, then it has a maximum, right? And how wide or how narrow depends on how close it is to 0, right? If the A is really, really close to 0, like 1/3, it's going to be wide. 1/3 ain't even on 1 yet, right? That's wide. But if it got an A of like 6, that thing look like this, right? Why? Because you're going out 1, but up 6 before you get your first point. So it got a curve from the vertex all the way up. Are y'all following me? Versus if I did an A of 1/2, it goes right 1, then it goes up 1/2. Look how wide that is. Out 1 and then up only 1/2. It got to go from the vertex to that point. That's a wide curve. Are y'all with me? So the closer it is to 0, the wider it is. Yes.
You know, so it's like big numbers too.
Like 10?
Yeah, like 10,
12?
20.
Yeah, but that's like, those are graphs you wouldn't even do. Why? Because that means you're going right 1 and up 20. You know what I'm saying? Like the chances of you making that curve, they wouldn't even bother you with those. But if they asked you which one is more narrow, it would be the one with the bigger A, right? All right, good question. Everybody good here? Any questions? Nope? All right, now let's talk about this B. What does this B do for me? All right, so B, you know, before I do B, I want to do C. Let's talk about C first. So C, make sure you put this in your notes. C gives us our y-intercept. What is the B in a linear function? What is this? Y-intercept, also called the, what else is it called? What else is that called? Your initial value. What else? Come on. It's your initial value. It's your y-intercept. It is your starting point, right? It's your starting point. It's your initial value. It's your y-intercept. All those things mean the same thing, right? It is your ordered pair where the x is 0, right? So this is your starting point, your y-intercept. What is that? It's not a guessing game. I already told you what it was. I'm just asking you to repeat it. It's your what? It's your y-intercept. It's the exact same thing it is in the linear function, right? That constant is a starting point or a y-intercept. It's the same thing when we look at a quadratic function. Are y'all following? Yes? Yes. Now, so this tells me my y-intercept. It's going to tell me where my parabola crosses the y-axis. In this case, this one crosses, this is the y-axis. This one crosses the y-axis at, what's this point? 1? At 1. Are y'all following? So this has a y-intercept. This parabola has a y-intercept of 1. Okay? Now, what else do we know? Just from looking at standard form, I can figure out a lot. 1, concavity, up, down, max, min, wide, narrow. C, where does it cross the y-intercept? I can tell you exactly where it's going to cross the y-intercept, right? B, what is B? B is a little bit more complex, but B is good information. B gives us our shift from the y-axis. It gives me my shift. It tells me, okay, did the vertex shift left or did the vertex shift right? It gives me my vertex shift. It tells me where my vertex moved. Did it move to the left or did it move to the right? Right? Now, how do I decide that? Well, B by itself doesn't do that. B along with A tells me that. So watch this. In your notes, write down AB positive and AB negative. AB, what does that mean? When you got two letters next to each other, what does that mean? Multiply. So AB means A times B, right? If you multiply A times B and it comes out to be positive, then what does that tell me? That tells me that my whole parabola shifted to the left. If AB comes out to be positive, I will see this point right here, this vertex, somewhere on the left side of this y-axis. It means this whole thing shifted left. Are y'all with me? If my AB is negative, what does that mean? It means the whole thing shifted to the what? Right. So when I look at my vertex, I should see my vertex to the right of the y-axis. Are y'all following me? I should be able to give you 4 graphs and give you one equation and say, which one of these graphs go with this equation? Why? Because you can see if it turned up or turned down, right? You can see if it was wide or narrow. You can see if it shifted left or the vertex shifted right. And you can see where that parabola crossed the y-axis. Are y'all following me? All those things we can get from standard form. Are y'all following me? Is everybody listening? Yes? Okay. So we use these things to help us identify what is the best graph that's representing the function. Why? Because on the ELC, it's going to give you graphs. And it's going to say, which one of these equations is the best equation to represent this function? And so you're going to look at it and you're going to say, okay, my A is positive, so this thing should... My A is positive, so this thing should curve up. It should be a U that goes up. Why? Because my A is positive. I have a minimum or a maximum. Minimum if it U's up, right? What if your A times B is positive? What shifted to the left? The whole parabola, which is controlled by the vertex. What's the vertex? The lowest or the highest point, right? So what am I looking for? If it shifted to the left, I'm looking for this vertex to be to the left. of the y-axis. Y'all see that? Here's my question. This vertex, where is it? Is it to the left or is it to the right? This vertex, where is it? Did it shift to the left or right? So guess what the B would be? 0. Because is 0 positive? Is 0 negative? 0 is not positive or negative. So that means there was no shift. Are you following me? So in our example that we got for our work that we did this morning, right here, look at this problem. What was our B? 0. So guess where this parabola is going to sit? In the middle, on the y-axis. It's going to sit on the y-axis. Why? Because it didn't shift. Let me give you a real life example of what that looks like. Let's say, somebody's standing on a building, right? Let's say this is a crime scene. This is a crime scene. You better do what you need to do. This is a crime scene. Somebody's standing on the building, right? 10 minutes later, we hear a scream. Somebody on the ground, right? Investigators come out. They're looking. What are they about to do? They about to use quadratics. They about to use quadratic functions. Why are they using quadratic function? Because something was up and came what? Down. And they need to determine what happened. Are you with me? Because bodies don't fall just flat down. It goes out. Are y'all with me? So in order to determine that, it is going to use quadratic functions. Watch this. If the body was pushed, is it going to just drop down? No. It's going to have a shift. It's going to have a shift from where it started. I see the building. The person was on the building. They were on the building. The person was on the building, right? But what happened? They didn't just fall down, because then that would have made this the vertex. Are y'all with me? What happened? The person had to be pushed because they went out and then fell. Are you all following me? So because there was a shift from this place, a shift, and if we're looking at it like this, there was a shift to the right, right? If there's a shift to the right, it creates the rest of that parabola. We know that the person was pushed, right? But if there was no shift, like how we got here, and the person just rolled down, then we know that they just fell. It was not a push. It was just a fall. Why? Because they went straight down. Are you all following me? This was their maximum point. There was no new maximum point. Are y'all following me? So we could tell a lot about anything based on quadratics, right? And quadratics can be used to solve a crime. Just like I just finished saying. Let's look at what happened. What does parabola look like? How far did this person fall over? Where did they end up? How far are they from the building? How long did it take them to get there? What time did we hear a person say they heard somebody scream at this time on the clock, right? So how many minutes later did we see the person end up on the ground? Like, there are so many different things that we can use to help us work backwards and figure out what happened in a crime scene, right? So it's important for us to understand the different parts of the quadratic function and how they help us. What does A give me? One word. What does A give me? What does concavity? What does concavity mean? Bend. Bend what? Bend up or down. What determines that? Minimum, maximum don't determine. What determines it? The A. If the A is positive, it bends up and therefore has a minimum. If A is negative, it bends down and therefore has a maximum, right? What else does A tell me? Yeah, it gives me the bend up or down, but what else does it tell me? Narrow or wide. How do we determine that this thing is going to be narrow and not wide? How far the A is from 0. Because if the A is 0, what kind of function is it? It's linear. If the A is 0, that means there is no x squared. That means it's a line. But the minute you introduce that x squared, that A, now I got to bend. And how much I bend depends on what that A is. If it's close to 0, the line's still kind of flat, right? It's kind of wide. But if it's a lot greater than 0, then now that line starts to bend more. Do y'all follow? All right. Then we have B. What does B tell us about our function? Patrony. What does B tell us about our function? A shift. How far we shifted from the... What if there's no B? Or what if the B is 0? Then what does that mean? You're in the middle. You didn't shift left or right. You right there. Are you all with me? However, if A times B, when I multiply them two together, when I multiply A times B and it come out to be positive, what does that tell me? That it shifts which way? A times B is positive. Now we want to say right. Right? That's our natural instinct, but it's the opposite, right? So if A times B is positive, what happened to that parabola? It went to the what? It went to the left. If A times B is negative, what happened to that parabola? It shifted to the right. The vertex of that parabola shifted to the left or right. Are y'all following? And then last, what about that C? What does that C tell us? It just tells me where the parabola crossed the y-axis. Now here's something that's cool. If there is no shift, then where is the parabola sitting? In the middle. On what? On the y-axis, which means it is the y what? Intercept. So if there is no shift, then wherever that vertex sitting, that is the y-intercept. Remember, because it didn't go to the left? Left. Points. It didn't go to the right. It's sitting on the y-axis. So if it's sitting on the y-axis, the vertex is actually the intercept. Because it ain't go nowhere. Are y'all following me? Does that make sense? I'm going to show you right here in this picture. Is there a shift here? No. Because it's sitting right on the what? Y-axis. Therefore, the vertex is the y-intercept. It's sitting there. So it's the y-intercept. So that's kind of cool. When you know you don't have a B or your B is 0 and there was no shift, you don't have to go find your vertex. Your vertex going to be your y-intercept. Does that make sense? Yes? All right. So I want to move past this and I want to look at our problem from today. So let's solve this quadratic function that we have here. Okay? Let's go. Our rule was y equals x squared. Give me the rest. 2x squared? I gave y'all 2x squared? 2x squared plus 4x minus 4x minus 8. All right, let's go through the motions. What are we doing? We are solving this quadratic function. How are we going to solve it? First of all, how do we know it's quadratic? Because it has a 2 as its highest exponent. How are we going to solve this? We're going to use the Punnett square. I got 4 terms. Let me pop them in a Punnett square, right? So do what I'm doing if you ain't did it yet. We're going to create us a Punnett square. And we're going to throw each of these factors in, right? Each of these terms in. First term always goes in the first box. So 2x squared. That's where your A term goes, right? Your C term always goes in the last box, negative 8. And it doesn't matter where you put the other two. That's completely up to you. But I'm going to put here negative 4x and positive 4x. It doesn't matter. Either way. Is everybody good on the setup? Yes? Okay. Now, what am I trying to do? I am trying to solve this quadratic function. How do you solve a quadratic function? What is the solution to a quadratic function? It is the x-intercepts. What did I just say? It's the x-intercepts. It is the point where the quadratic function crosses the x-axis. Are y'all following me? Here, watch this. When I look at this picture, how many x-intercepts do I have? One. So there's only one solution for this one. When I look at this picture, how many how many x-intercepts are there? 2. Here and here. Those are my solutions. You with me? My solutions are 1, 2, 3, 4, 5, 6, 7. 3 and 7. Here my solution is 0. Why? Because those are your x-intercepts, right? What's this ordered pair? 0, 0. 0, 0, right? What is this ordered pair? 3, 3, 7. This point? Where is it sitting? On the x-axis. So what is the y?
0.
So then what's this ordered pair? 3, 0. What is this ordered pair? 7, 0. So what do all three of those solutions have in common? The y is what? So anytime we're trying to solve a quadratic function, we want to have our y be 0. And if we can solve it with our y being 0, you didn't sit back there to go to sleep, then that is going to be your solution. Are y'all following? All right, so let's go. All right. Can you pause that? So what are we doing? We are solving this. We're trying to find a solution of a quadratic function.
Teachers and students, please pardon this interruption. We are not evacuating. Please stay in your class. Again, we are not evacuating. Please stay in your class.
We are trying to find the solution to a quadratic function, right? And we cannot, to find a solution to a quadratic function, you got to find the x-intercepts. How do you find an x-intercepts? You plug in a 0 for the y. So our goal, no matter what kind of problem, no matter what way we use, whether we use table, graph, factoring, quadratic formula, or completing the square, it don't matter. What are we always looking for? We're looking for the x when the y is 0. That's going to tell me my solution. I can have one of them because it hits once. I can have two of them because it goes through and hits twice. Or I can have none because this could be my x-axis and my parabola could do this. Did it touch it? No. Or it could do this. It's my x-axis. It could do this. Did it touch it? No. Right? So if it bends down below or it curves up above, it may never touch it. So then you got what? No solution. Are y'all following me? So what are my possible outcomes? I can have how many solutions? 1, because it touched it once. I could have 2, because it went through it twice. Or I can have none. No solutions, because it curved above or went below, right? So let's look and see what we're going to end up with this, right? So let's start first things first. We are about to solve this quadratic function. And what method are we using? We are using what we call factoring. I am looking for what they have in common. Are y'all with me? And I'm going to show you how this actually works out. Watch this. How do you get 2x squared? So it's 2 times x times x. Do you agree? Do y'all agree? Yes? How do you get 4x? 4 times x. How do you get negative 4x? Negative 4 times x. And how do you get 8? You can do negative 2 times 4, or you can do 2 times negative 4. Do y'all agree? Yes? All right. What is the only way to get 2x squared? What do you have to multiply? You got 2x, 2 times x times x. So tell me, what do I write here? 2x times x. Does that make sense? Yes? So I got 2x times x. That's how we get 2x squared. This is my base times my height gives me my area. Does that make sense? Yes? Now, how do I use this 2x to help me get what goes here? So I could put it here, right? So this is 2x. 2x times what is going to give me 4x? 2. So that means this must be a positive 2. Does that make sense? Yes? How do I know that? Because base of 2x times the height of 2 is going to give you an area of 4x. Does that make sense? Once you got one side, it don't take nothing to get the other side, right? What do? X times what is going to give me negative 4x? Negative 4. And now I need to look at my two numbers that I got here. This is negative 4, so that means this base is negative 4, right? This is 2, so that means this is 2. Negative 4 times 2, does it give me negative 8? So then I know I did it right. Are y'all following? What did you just do? I just factored. What does factor mean? Factors are numbers that you multiply to get a product. What numbers do I multiply to get this product? 2x and x. What numbers did I multiply to get this product? 2 and 2x. What numbers did I multiply to get this product? X and -4. What numbers did I multiply to get this product? -4 and 2. I just found the factors, so therefore I am factoring. Are y'all following? Does everybody understand that? Yes? Now, I'm going to do this, because this is where the magic happens. I did that for a reason. So now I am ready to multiply. I'm ready to solve. Let's go here. Our problem was y equals 2x squared plus 4x minus 4x minus 8. You said we could simplify this, right? We could simplify these by putting these two together, right? And we would end up with y equals 2x squared plus 0x minus 8. Y'all with me? Yes? That's standard form. What's my A?
2.
What's my B?
0.
What's my C? Negative 8. I just put this in standard form. What is standard form? Y equals ax squared plus bx plus c. Y'all with me? Now, I can go a step further because we know we don't need that 0x, so it can really be 2x squared minus 8. What if you saw it this way? What is your A? 2. What's your B?
0.
Still 0. How do I know that? Because I don't see an x, so that means my coefficient must have been 0, right? And what's my C? Negative 8. We're recording, right? Okay. Now, this is my rule in what form? Standard. And we already know from standard form we can identify multiple things. Concavity, up or down, max or min, wide or narrow, right? We can also tell you if there was a shift or not, right? And we can also tell you what the y-intercept should be when it crosses the y-axis. All those things we get from standard form. Are you following me? Now, what's the other form? Factors form. So factors form, I'm going to go ahead and write it in factor form. Put y equals. Then I'm going to put 2x. Where I'm getting this from? What we had right here. 2x minus 4. And then what is this going to be? X plus 2. Where did I get those from? Right here and right here. Is everybody with me? These are my factors, and I'm writing my thing in factor form. Is everybody good? Yes? Now, Ms. Stampley, how are you going to use that to help you? Well, what did we say was the solution to a quadratic function? It's the what? The x what? Specifically, not any x, which x's? The x-intercepts. And what do y need to be in order to find x-intercepts?
0.
So guess what I'm gonna do? I'm gonna rewrite this factored form. And instead of y, I'm gonna put what?
0.
0 equals 2x minus 4 times x plus 2. Why did I put that 0 in place of y? Because I need the y to be 0. Why do I want the y to be 0? So I can get the x-intercept, right? Because what is y when you're looking for x-intercepts? It's 0. What is x when you're looking for y-intercepts? 0. Are y'all following? So the fact that I plugged the 0 in here means I'm looking for the x-intercepts. What are the other names for x-intercepts? Roots. What else? Solutions. One more. What are they? Zeros. So our x-intercepts are called, for those that weren't here, our x-intercepts are our solutions. They are also called our roots. They're also called our zeros. They have multiple names. They are your zeros. They are the numbers that you get when you plug in 0 for a y. They are your roots. They are the points that sit on that y-axis. It takes root, like that's the ground. They are your solutions, right? They are the answer that we're looking for, and they are your x-intercepts. They are the point where your parabola crosses the x-axis. Are y'all following me? So let's find our roots, our zeros, our x-intercepts, our solutions. Now, I want you to look at this. We plugged in 0 for y because we're looking for x-intercepts. But now this becomes a multiplication problem. Something times something gives me 0. Do y'all see that? Everybody see that? I could even rewrite it like this. 2x minus 4 times x plus 2 equals 0. Same thing. Something times something gives me 0. What's the only way to get a 0 when you're multiplying? You gotta multiply by 0, right? So what does that mean? If I know that that's true, that to get a 0 out when you multiply, something got to be multiplied by 0. That means that either this, Jonathan, is 0, or this is 0, or both. Because 0 times this gonna give me what? This times 0 gonna give me what? Or 0 times 0 gonna give me what?
0.
So that means at least one of these gotta be a what?
0.
So guess what I'm gonna do? I'm gonna set them both equal to 0 and see how do I make them become 0, right? Some number times 2 minus 4 gotta give me 0. Some number plus 2 gotta give me 0. Otherwise, I couldn't get a 0 out there. So watch what I do. I'm gonna write 2x minus 4 equals 0. And then I'm gonna say x plus 2 equals 0. Why am I doing that? Because I want to know what will x have to be in order to get one of these to be 0. So let's solve it. Draw my squiggly. What's the first thing I do if I'm solving for x? Add 4 on both sides. So I'm going to add 4. Add 4. These cancel out. I get 2x equals 4. And then what's my last step? Divide everything by 2. By 2, by 2. These cancel out. X equals 2. What does this tell me? That's a solution. Give me another name. That's a what? That's a root. It's a what?
0.
It's a 0. One more name. It's a x-intercept. The parabola that uses up and has no shift is going to cross the x-axis at 2. Is that its only solution? We got another one. Let's go. What do you do? Minus 2 minus 2. Right? What do we end up with? X equals negative 2. So we got 2 solutions here. We got positive 2 and we got what? Negative 2. Will it always end up being positive 2 and negative 2? Like if you got a positive 3, it's going to be negative 3, or a positive 5, you're going to get a negative 5. Is it always going to be that way? No. When is it like that? When your vertex is sitting on the y-axis. Because if one solution is 2 units to the left, guess what the other solution going to be? 2 units to the what? Right. Why? Because your vertex is always right in the middle of your parabola. Are y'all following me? It's always in the middle. So it's always going to be the same distance from each one of your solutions. Always. Right? So this is our solution. I want to show you that this is true. Watch this. This is our rule. Y equals 2x minus 8. Y'all agree? Yes?
Yes.
2x squared minus 8. Here's our function. Look at our solutions. What is that? And then what is this? 2, 0. Y'all with me? This line, do y'all agree this line falls right in the middle? Yes? This line will be called our, I want you to write this down because this is what this line will be called. Just make you a quick U. It is called our what? It is called our line. This is called our line of symmetry. What is the line of symmetry? It divides your parabola in half. How far is this point from the line of symmetry? Let me put the line of symmetry officially in there. Watch this. It is going to be x equals 0. X equals 0. So watch this. Here's the line of symmetry. How far is this point from the line of symmetry? 1, 2 spaces to the left. Y'all see that? How far is this point? 2 spaces to the what? Right. It's always going to be like that. Let me show you one more space. Watch. Let's say I pick this point. What's this point? -3? And what's this? +3. Isn't it 3 spaces to the left, 3 spaces to the right?
Yes.
Even if we keep going, we're going to find another one. Let's say we're here. This one is -4, right? What this one going to be? +4. 4 spaces each way. Are y'all following me? Why does it come out to be -4 and +4, -3 and +3, and -2? Why? Because it's sitting right on the vertex. Here's the vertex. Right here is our vertex, and it splits our parabola in half. Is everybody following? Now let me show you something that's real cool. If you're trying to find the A, watch this. If you're trying to find the A from a graph, you could do this. Here's the vertex. Y'all with me? We're going to go out 1 unit to the right, and then we're going to go up. What was our A for this one?
2.
It was 2. If I go out 1 unit, to the right, how many spaces do I have to go up to hit this line? 1, 2. Y'all see that? That's how I knew the A was 2. You start at the vertex and you go out 1 space. I went out 1 because this is 1. And then I got to see how much I got to go up or down to reach the parabola. Well, I went up 1, 2 spaces, so that means the A is 2. We can even get our A from our graphs, right? So anyhow, we just solved this. We found our solutions. They are, what were our solutions? -2 and what? +2, and those are the solutions. That's the whole point of us solving, is to find where this parabola crosses the x-axis. Are we all good there? Yes? Quick recap. I got 4 terms. First term goes in the first box, right? First term goes in the first box. First term goes in the first box. Last term goes in the last box. Right? 2 middle terms, don't matter where you put them, but they go in the middle, right? What do? What do I need? What factors do I need to make this? 2x and x. Why? Because when you multiply those, you get 2x squared. Y'all with me? Now, I use them same numbers to help you with all the other boxes. Got x already, so I need a -4 here. I got a -4 here already, that means I need a +2 here. So now my whole thing is filled in, right? What do I do now? I'm going to take my factors. What are your factors? The 2 numbers, this and this, multiplies to give us that. Are y'all with me? I'm finna show you something. Watch this. What if I did this? Matter of fact, let me show you distributive. Watch this. I'm gonna do 2x minus 4 times x plus 2. Y'all see where I'm getting these 2 from? Yes? Watch this. Work with me. What's 2x times x? 2x squared. What's 2x times 2? +4x. What's -4 times x? -4x. And what's negative 4 times 2? Negative 8. Do you see that I got the same thing we started with?
Yes.
So do this factor and this factor when multiplied give me this product? Yes. Are you with me? That's how I know I got the right factors. So now, once I got the right factors, right, I can take those factors and put them in factored form. 2x minus 4, x plus 2. And what am I going to do? I'm going to set them equal to 0. Why are we setting them equal to 0? Because we want the... Why we want the y's to be 0? Because we're looking for x-intercepts. Why are we looking for x-intercepts? Because they are the solutions to the quadratic function. That's why I'm doing this in the first place. I'm trying to find the solutions. So I'm going to plug in 0. But there's a 0 product property. 0 product. 0 multiplication property. 0 multiplication rule. What does it say? If you multiply by 0, you're going to end up with what? 0. So because I know that to be true, I want to set both of these equal to what? 0. Because one of them got to be 0, or both of them, in order for this thing to come out to be 0. So I said 2x minus 4, my first factor to 0, my second factor to 0, and I solve. And what I end up with is my x-intercepts, which are my solutions, my roots, my zeros. It's the whole reason I just did this. It's to find where does this parabola cross the x-axis? At 2 and negative 2. And we saw that on the graph. Are y'all with me? Is everybody following? Yes. All right. Can you stop that?